Hello, I'm about to teach Introduction to Trigonometry. This is for absolute beginners, people who have never learned trigonometry before. You've heard the term, someone's learning about trig or trigonometry. That's what we're learning today for the absolute beginners, what trigonometry is. I'm going to start off with a question. What is tan of 30 degrees? Okay, I'm going to talk about the meaning of this question, not necessarily what the answer is. And here's just an example. If I say 7 times 3, what does it mean? 7 times 3 means 3 7. 7 plus 7 plus 7. That's what it means. When we know what it means, maybe, hopefully, we'll get the answer, which is 21. So I'm going to talk about the meaning of the question. And just a reminder, before I continue with this question, trigonometry relates to angles. Angle is a measure of rotation. Okay? Here's an example of two angles. Which is the bigger angle? Believe it or not, that's the bigger angle. That's a bigger picture. The lines are longer, but angle refers to how much something has opened up. This has opened up more. It's a bigger angle. I can extend these lines. I could take a ruler and draw these two lines on and on. The angle will not change. The angle is how much in a circular method has opened up. One way to measure angles is with a protractor. I can come to that in another lesson. There are many ways to measure angles. The extent something is open. It's like length of something. You can measure in inches, centimeters, kilometers. Same thing with angles. For today's lesson, I'm only going to stick to degrees. Degrees is one way to measure angles. So one particular angle is 30 degrees. If it opens to a certain amount, it's called 30 degrees. What's the tan of 30 degrees? Okay. The meaning of tan of 30 degrees is if I have an angle, a triangle with 90 degrees and 30 degrees, I attach names. The longest angle, the one opposite 90, is always called the hypotenuse. The other angle next to the angle we're referring to is called adjacent. And the other side not touching our angle is called the opposite. Okay? If I take a triangle with 90 degrees and 30 degrees, the tan of 30 degrees means this opposite divided by that. The length of the opposite divided by the length of the adjacent. That is what the tan of 30 degrees is. Okay? If I say, what's the tan of 45 degrees? That means I take a triangle with 90 degrees. 90 degrees is like a perfect corner, like in most rooms. And that's 45 degrees. The length of the opposite divided by the length of the adjacent is what the tan of 45 degrees is. If I said, what's the tan of 10 degrees? If I had a triangle with 90 degrees and 10 degrees here, the length of the opposite divided by the length of the adjacent. But then you might say to me, but what happens if it's a bigger triangle with 30 degrees and 90 degrees? Because it's in the same proportion, that opposite divided by the adjacent will give you the same answer. It just so happens tan of 30 degrees equals 1 divided by root 3, or the decimal corrected 3 points is 0.577. If I take my calculator and I press 30 tan, I will get this answer. Depending on the calculator, some calculators you press 30 tan, others you press tan 30, but that's on the calculator. But that's what the tan of 30 means. This length divided by that length. And I'm going to say something that, and also, of course, the tan of 45 degrees happens to equal 1. If you have a triangle with 45 degrees here, the opposite and adjacent are equal. That length divided by that length will always equal 1. And again, it's in proportion. It doesn't matter how big or small the triangle is. It can be an enormous triangle, but with 90 degrees and 45 degrees, opposite over adjacent will equal 1. The same way, it doesn't matter how big or small this triangle is. If it's 30 degrees and 90 degrees, this length divided by that length will always give me the same amount, which is 0.577. And I'm going to say something that's now looks strange. I'm going to draw a triangle here. And I talk about the tan of this angle. Now it's going to look a little bit confusing. A minute ago, I was talking about triangles must have 90 degrees. How can you talk about a tan of this angle if this doesn't have 90 degrees? Remember, I said the tan of an angle means if you put it into that triangle. That means if I took, I'm going to draw it while I'm talking to you. It means, let's say if I measure this angle, let's say it also is 30 degrees. That's if I had to take this angle and redraw it into a triangle with 90 degrees, what would opposite divided by adjacent be? So a good way to think of it, if I say someone's allergic to a particular food, it means if they eat that food, they will react. It doesn't mean they're reacting. It means if they eat it, they will react. The tan of this angle means if I put it into that triangle, what would opposite over adjacent be? It doesn't even need to be a triangle. Here's an unusual shape I just drew. What's the tan of this angle? It means if I took that exact angle there where my finger is, I redrew it inside a 90-degree triangle, what would the tan of that angle be? It doesn't even need to be a closed shape. I'd say, what's the tan of this angle? It means if I put this angle into a 90-degree triangle, what would that opposite over adjacent be? And what I love doing with mathematics is giving examples how we use it to give it meaning. Like at this second, you're saying, well, it's all nice saying, well, tan is the opposite over the adjacent in a 90-degree triangle. But who cares? Like, why must it have a special name? I'm going to explain a perfect example. Now you know why I taught mathematics and not art, because needless to say, I'm not the world's greatest artist. The only thing I can draw is a mess. Anyway, let's say we have a building, all right? And we need to calculate the height of the building. I guess we're going to paint it and do other work on the building. For some reason, it's no longer in the records. And it's rather difficult because you can't exactly walk up the side of a building with a measuring tape. So what can you do? Let's say, provided, of course, the ground is completely flat. We go to some point from this building, and with some instrument, we know we're exactly 40 meters from the bottom of this building. And we notice from this point to the top of the building is an angle of 50 degrees, okay? Now, what we can do is, we know that tan of 50 is the opposite over the adjacent. If it's a 90-degree triangle with 50 degrees here, it doesn't matter how big or small that triangle is, the opposite divided by the adjacent will always give the same amount. So if I plug in to my calculator and I say, what's the tan of 50? I'll even try to see it in front of you, if it's possible. There's 50. There's a tan button. And it's 1.19175, and the digits continue. So for simplicity's sake, I'm going to stop at the 5. According to the calculator, I did it ahead of time. Tan of 50 is 1.19175. And what we do know, that opposite over the adjacent in a 90-degree triangle is always the same, no matter how big or small the triangle is. I just called the height of the building h for height. H over 40 equals 1.19175. Opposite over the adjacent is the same for any 50-degree right triangle. So h over 40 must equal this number. Now I do the arithmetic. It's an equal sign. I multiply both sides by 40. H equals 40 times this number, and it comes to 47.67 meters. See how I use trigonometry? Opposite over adjacent is the same for any 50-degree triangle with right angles. So height over 40 must equal the tan of 50, which is 1.19175. I have just used trigonometry to solve a problem. Now, when I started off, here we go, I gave these angles names like opposite and adjacent. I spoke about tan, and there's more other terms. Sin is the opposite over the hypotenuse, and cos is the adjacent over the hypotenuse. And of course, I can use these as well. Perfect example, let's say this building, we're now going to attach a wire from this point to this point. How do we measure the length from there to there? Well, remember I said cos is adjacent over the hypotenuse. There's the adjacent, there's the hypotenuse. If I punch in my calculator what's the cos of 50, I get 0.643 related to 3 digits. I call this W for wire. Adjacent over hypotenuse will be the same no matter how big or small the triangle is. So adjacent is 40, we call this W. 40 over W is 0.643. And I use regular algebra. I multiply each side by W, divide each side by that. I do the arithmetic, and it simplifies. W equals 62 meters. That's to the nearest digit. We'll make it 63 to be safe. So I just did cos. I said cos is adjacent over hypotenuse, 40 over W, and the calculator says it's 0.643. 0.643 is 40 over W, and I did algebra, and we solved for the length needed for the wire. That's the absolute introduction to trigonometry. Of course, it carries on from there, and I gave a beautiful examples how you can use it in real life. And one of the most common uses of trigonometry is measuring things that you cannot measure directly, like the height of a building. You can't quickly run up with your measuring tape. You have to measure the width across let's say it's a highway. You're going to build a bridge, and if you need to build a bridge from this point to that point, you can't quickly walk across above with a measuring tape. You can use trigonometry to find that length, etc. Anyway, I hope you liked that introduction, and I hope to continue teaching you more. Brought to you by Martin Tutorials.